The focus of this presentation is to give you some detail what the Net Conductor is, why it is of value, of course, which is pretty obvious, and some of the underlying technology and how it's integrated into Central and CX. So, and to finish, we've got a demo as well, followed by Q&A. So I'm covering the first three topics. It should take us about 25 minutes to get through these, and Corey is going to run through a demo from our Roseville TME labs. That will be about 15 minutes long, and then we'll go straight into Q&A. So first of all, what is it? I find this a very important question because going back a year, I didn't know what NetConductor was. I didn't even know it's part of Central. So although it's a very basic question and very easy to understand, I thought it's obviously a good point to start. So first of all, it's a solution architecture framework integrated into Central. So there isn't a reference to NetConductor anywhere in the Central UI. You won't find it. It's an umbrella term for these layered architecture framework, which is intending to support from the remote edge all the way through to the data center. So today the focus is on what we have today, and three key elements: the fabric, policy, and infrastructure is what we have. And first there is the fabric wizard. So we have the overlay fabric wizard for orchestration today. This includes BGP, EVPN, VXLAN as an overlay. The underlay orchestration capability is coming later this year, so we don't have it right now. So for releases 2.5.5 and 2.5.6, the underlay is a manual configuration, and this needs to be in place prior to using the fabric wizard. But you'll see all this as we go through the further slides and also in the demo. So first of all, the policy layer. In the policy layer, there's a variety of options, of course, that we have. First of all, is ClearPass, which provides the richest experience for customers, either on-prem or in the cloud. Then we have CloudAuth for smaller, simpler deployments, and also integrations with third-party NAC solutions as well. And client insights. So a very important part of Central, integrated with the NetConductor architecture framework for profiling, and also can be used as an input into our NAC solution like ClearPass. So the sweet spot for the NetConductor Fabric Manager and its orchestration for security right now is in the campus. The campus to DC to cloud capabilities will arrive later this year, but that's not to say that you can't position obviously Central for a customer, for any customer that wants to actually manage their data center portfolio. We also have for 2.5.6, we've got now monitor only, which means that you can have Central in monitor mode for a particular group and the switches inherent in that group, and you can use another management tool like the Aruba Fabric Composer for orchestration and ongoing management. So from past presentations, some of you may be familiar with the NetConductor, just a fabric manager, and that was originally how it was positioned. But of course, the sum of the integrated Central components makes it much more than that. So now with this full stack solution that we've got for that network and security framework, we've got this umbrella term, the Aruba Central NetConductor. So first of all, at a high level, the NetConductor is an evolution of dynamic segmentation, and this provides more flexibility for customers that want the key features of user-based tunneling with Aruba gateways, but not the centralized limitations of scale. So customers can now have the orchestrated capabilities of leveraging a distributed overlay model with VXLAN, EVPN, and integrating the security policies to various roles as well. So customers do have a choice. They are not mutually exclusive for each other. So customers can leverage one or both solutions on different parts of the network, depending on their need. And the nice part about it is that the security policy framework will integrate between the two. So the other key point is role-based policy enforcement from Central, all managed from Central down into CX Switching. And of course, the big part of it is that fabric orchestration overlay today. Then I mentioned the flexible NAC options, clear pass on-prem or in the cloud, or third-party NAC solutions or cloud auth. And the AI-powered insurance, that's Central's AI and machine learning capabilities, big part of that integration into NAC solutions as well, and get visibility of what's happening with the edge devices. So I just wanted to talk about this bit here, because our eyes will prick up what's investment protection. So because we've got standards-based solutions with EVPN, VXLAN, we can interoperate with other vendors. So we can leverage the access layer first if it's a new customer, for instance, while customers can still have their Cisco core and aggregation. And then obviously we'll have to do a manual integration at the edge to their aggregation and core, but the security framework can be end-to-end and leveraged by Central with the Net Conductor. So it doesn't have to be all or nothing. So it all adds up to this part here. The big important part is the Zero Trust security model. This is from the perspective that customers can eliminate that implicit trust model, move to a default deny model, and customers can then decide which devices and users can communicate with each other. So that is Net Conductor. You won't see it in the UI. It's a series of integrated technologies. Some are already there, but they're all inherent to Central, and we obviously get this single pane of glass to make it ease of use for customers to actually leverage these technologies and solutions. So why use it? Pretty obvious, I think, but I just want to talk around this because we have customers talking to us about these very challenges. So let's quickly go through a couple of points. Let me have a quick sip of water. So we talk about digital transformation, and the whole term has been around for a long while. We've all heard of it. It's a well-traveled path, a bit of a buzzword, but it's not just about a conversation about moving applications to the cloud, although invariably that becomes a big part of the transformation story. It might be just about improving customer experience, increased productivity, or just accelerating solutions to the business. All common themes with our customers, so it means different things to different customers, and they are talking to us about these challenges. So first of all, network sprawl. We've all heard about it, read it. I'm sure we've had customers talk about it to us. Disparate network management tools. Customers end up using different tools for different pieces of the network, and all adds up to this complexity for policy management and also the underlying configuration. So we have customers coming to us all the time, or frequently asking us about how we can help them, and this is around automation, simplifying their operations, speeding up their service delivery. They're all top of mind, and we certainly can help them with Central and the automation orchestrating capabilities that we now have with Net Conductor. So if we take an example, and we know this, but I'm just going to put it up there so we just reinforce some of the challenges. They still go on to us about the challenges they have and why they need to move away from it. So this is a traditional network design. It's been around for 7, 5, 10, forever. We're seeing VLAN sprawl, policy constraints aligned to VLANs, excessive VLAN consumption, incoherent or lack of uniform configurations across the network. This demand for ever increasing demand for layer 2 networking, obviously not easily or typically from an architecture design perspective desired across aggregation blocks, but customers often link these two, and I'm sure you may have seen this happen, not because they want to or the IT network team wish to do it, they're pressurized by the business to deliver a solution. So all this adds up to the complexity of the network, and it's probably easy to say that the best practice of 5, 7, 10, 15 years ago it just doesn't stack up now, and really no longer fit for the modern day network, especially for medium-sized campus and large campuses. So we do have the technology solutions around in the marketplace, and we know that, we're aware of them, of course. The ubiquitous nature of EVPN VXLAN, for instance, is one solution. No longer is VXLAN with EVPN seen as a data center network technology. The benefits apply equally to the campus, especially as we see the trend for data at the edge. And the model of distributed gateways, VLANs at the very edge of the network across all edge switches, we know this is a powerful enabler for our customers. And then we've got the orchestration part of NetConductor, and it's very easy to underestimate this type of capability when you look at what it delivers to customers in the terms of that tidy configuration that's error-free very quickly and speedily, especially as if you've seen a customer's change control process and the pain they go to in developing configurations, getting it checked, and then getting it to roll out. And the nice part of the solution that we have is that we've got this integrated security policy from the overlay part of the network and also to the UBT gateways that could have a tunneled from locally devices to our UBT gateway, or from a branch. We can have this coherent security policy framework deciding which devices are connecting to other devices. Very, very easy to use in that respect. So this automation of the security policy is one of the big enablers from an operational management perspective. All you need to do is click on the radio buttons. That particular role, and the role could be aligned to a functional device, for instance, or a user or a user group, for instance, and you decide which devices or users can communicate with each other. And it's that easy, and that is then pushed down to our overlay network. So on the narrow theme of orchestration and why this is important for customers, so if we look at what we have to push, the customer wants you to push down an overlay configuration. We've seen this, if you're familiar with BGP, VPN, there's a lot of config to go down with the overlay network, VXLAN tunnels. There's going to be some interfaces there, the VLAN SVIs. And then on top of that, of course, if you want to integrate a security policy architecture framework with it, with GBP, group-based policies, VXLAN, for instance, then this is just a snip of just one role connecting to another role. So that's an awful lot of CLI config. So very, very difficult for customers to roll out. So of course there is an easier way, and we have it. It's all packaged up with the NetConductor in an easy to use interface workflow from start to finish. You can even get a little diagram as well, just to give you a heads up of what your device operational mode should look like. And you can just run through this wizard very, very simply. If you're familiar with the Fabric Composer, similar concept. Obviously the presentation is different, but the idea is the same. And going back to capabilities of switch vendors, it's all very well having a capable switch network with plenty of advanced features, and we know we've got strong competition in this area with the various vendors out there. But if we just think about what the back of every customer's operational manager or senior manager's mind is when they're reviewing new network technologies, is the first thing that comes to mind is, how is my team going to manage this? Doesn't matter how good their features are, they need a clean solution to manage it. So if you take a look at one switch, I'm just going back to this CLI, so you can see it in a bit more detail, times it by 20, 30, 40 roles, pushed down to say 50 or 60 switches, edge switches. It's almost impossible to deploy quickly and with the manual process without area. So fortunately, the NetConductor Fabric Manager takes away all this pain for customers. So you'll see how we do that in the demo, and also some of the slides coming up. Right, I'm just going to take a sip of water, my throat to get sore. Right, okay. So let's go on to some of the building blocks that we have. Let's give some an idea of how it works underneath Central and the user interface. So for the micro segmentation part, it's all based on group-based policies, a draft standard that the IT industry is following. So it's an enhancement of the VXLAN header to provide a group policy, a role ID, and we map the user role to this GPP, the group policy ID. So what this means is that roles are no longer tied to the IP address for a device or a user. So source-based roles are assigned to a user at the ingress VTEP, and the policy follows the device or the user as they move across the network. So the main use case is micro-segmentation, but that's not the only one. We can apply policy to users and devices on different subnets as they move across the network, either on the same VLAN, different VLAN, or different VRF. So the group policy is applied at the ingress VTEP. After device authentication, the roles names are not sent between VTEPs, just the group-based policy ID, but obviously there's a mapping between the role and the group-based policy ID that's in the VXLAN header. And the policy is enforced on the egress VTEP, where both the source and destination roles do need to be present. So on the ingress VTEP, you can get away with the source role only, but it's generally good. It's good practice to have both roles, the source and the destination, on all the edge devices. So this is where automation is definitely required, because this on its own is a headache to manage. You could use a config editor like a NetEdit, and that would help out a lot. But of course, you're still basing it on a manual input as well. And of course, we've got Central to do it all for us, error-free. So that's the main advantage of going through Central, and it integrates down into our policy orchestration and our overlay fabric. And I mentioned that the Central NetConductor is obviously more than a fabric manager, and it's just more than an overlay manager. So we can integrate into the branch. So we take a branch solution with user-based tunneling to the branch gateway. We can assign a GBP tag. It's encapsulated in the SD-WAN header, and not the VXLAN encapsulated header, just the GBP tag, and that can be sent to a gateway cluster on the edge of our overlay network, and then we then get, this is how we get that end-to-end integrated security policy that we can manage from Central. And if we just look at the key components of the central NetConductor, so the policy level, high level architecture. This includes the physical infrastructure. There's three primary components. So the first is client insights, which is profiling clients for or devices for threat analysis, and based on that profiling with central insights, we can align specific tags can be shared with ClearPass, and then obviously ClearPass can then take an action based on these insights, either to block quarantine or apply a restricted role until some kind of remediation takes place. And of course, this is all part of the broader Aruba solution value add. So if we don't have ClearPass present, we could use another NAC device. So Cisco ICE, that's perfectly fine, and just the role would be returned. So we do have, obviously, and as I mentioned, in the cloud, we've got CloudAuth being for smaller deployments, simple use cases, no auth survivability, and only supporting Aruba only devices, but does support macauth, excuse me, 802.1x and basic role assignment. So after profiling, we can then, obviously, the part of the NAC solution is to map clients to roles, to bind a user or thing to an Aruba user role. And then we have obviously the policy manager in Aruba Central, and this is where we can configure roles and policies and decide who connects to who's allowed to communicate with which device. And this gets pushed down to CX switches and AOS-10 gateways. And of course, the underlying supporting technologies, VXLAN, GBP, the group-based policy. And this is enforced at the gateways and switches. And we still have, obviously, the option of having colorless ports and dynamic VLAN assignment as well. And that's obviously an option depending on the architecture and the design of the customer. So product positioning and the code support, where we are. So a bit like the Fabric Composer, each switch family has a distinct persona. I prefer to use the expression role for its place in the network, and this persona and role is an expression of the switch function, and it's there to ensure that the correct configuration is pushed down to the device based on its role or persona. So at the edge, at the traditional access layer for campus, we can have a variety of switches in our portfolio as edges. We do have different, obviously, persona or roles for different places in the network. Some of them are a bit unfamiliar. So edge is for an edge device. Stub, that will be for a device at the edge of the network interconnecting to a gateway, an Aruba gateway, with a static VXLAN tunnel. A route reflector, of course, would be in the spine of the network, and the border would be obviously connecting to interconnecting one fabric to another at the edge. And the other part of it is that all AOS gateways are supported. AOS 10 and above has to be on that AOS software level, and for AOS-CX, those specific devices 10.10 and above, and each device can be have multiple roles within a particular fabric, depending on the capability of that device and the central support for it. So you'll see this in Corey's demo. It's creating roles is very easy. So if we go into Central itself, we want to create some roles and define a connectivity policy, very easy to do. We have to start from global in the front, top level UI presentation, tab down to security, and then into client roles. And that it's here where you can add and edit roles, and there's a little tab on the right hand side here to add a role. I've got 3 roles in this particular screenshot, and if you wanted to edit it rather, then you obviously got the policy reference there that gets pushed down to the GPP tag in VXLAN. And if you're editing this particular role, for instance, this contractor 12, you then get the permissions that you wish to have it with the other roles that are defined, and you just click on the radio buttons to decide which the connectivity model you want. Very, very simple. And then once you've done that, save that particular policy, and then it gets pushed down to the desired edge switches. So very, very, very simple. And the fabric manager is equally as simple, and we had to go somewhere else for that. So it's actually in the group, and within that group would be the devices that you wish to have in your fabric, and you can select them through the fabric wizard. So the group is here, select devices, and then you get the main pane up, and then there's this tab for fabrics, select fabrics. And once you're into there, you then have the option of creating a fabric. You have obviously multiple fabrics to manage. This one I've already created a fabric called Fab1. If you want to create another one, just click on the plus and then run through this wizard. It's very, very simple. Add devices, add overlay networks, and stab tunnels, and then you get a summary and push it down. So very, very easy. So if we just step through this on add devices, you get a list of devices that are in the group that you selected at the top when you before you've selected the fabric wizard, and you select the appropriate devices, assign them the role or roles or personas that you wish them to have. You even get a nice little pop-up box of where to give you some insights of where they should be, and then just go through the wizard. Very, very simple. Once you add devices, go on to add overlay networks. This is where you can assign a VRF or add additional VRFs once you've created the fabric. And then you've got the stab device connectivity model from your gateways to your fabric, and then a summary at the end, and then you save it and it pushes down that overlay configuration, VXLAN, WAN, EVPN, BGP to your fabric. And of course, then on top of that, you need to be able the ability to add gateways, anycast gateways at selected switches or all your switches, edge switches in the fabric. So again, go back to the fabric itself, and then on here you get the option of creating a segment. I've got 2 already created here, and this is where you can create obviously your VLANs, your subnets associated to the SVI, and the anycast gateway, and also other options like DHCP servers, the relays, for instance, that you want to, and then assigning your roles to those VLANs. So they're all very, very, very simple, and it obviously takes longer to talk about it than it does to actually go through the actual wizard to create a fabric, to create a policy, and then push those integrated policies down into a fabric. It's a lot quicker to do it than it is to talk about it. So, which brings us on to Corey's demo. So I'm going to hand over to you now, Corey.
Much. Okay, so on the menu today, we're going to basically show off Network Conductor. This is our central instance in Roseville. We have a number of access edge switches in this topology, 2 8325s as route reflectors, got an 8360 as a border in the environment, and just a number of clients that are connected at the bottom with different roles. And only 2 client VLANs are at play, VLAN 12 and VLAN 13. And I've got traffic basically flowing. You'll see this with the role definitions, but I've allowed basically traffic between employees IoT role and the employees role. and then the employees and contractors are not able to talk to each other. And I've got some XC traffic that is flowing between the 6300 on port 3125 out to 1337 on the other side. So this is basically the topology. We just have some traffic so we can show you how things change once we alter the role definitions. So this is basically the topology here. I'll just pause for a moment if anyone wants to screen capture that, just to help with understanding what's going on. And let me go ahead and stop sharing this. Okay, and go ahead and bring up topology stuff. Okay, so as Steve mentioned, you get to the role definitions from within the global settings here, and then you go to security. And we go over to client roles. And so you can see I've basically set up 3 different roles as I just explained: contractors and employees, IoT. They each have a policy identifier that's specified, and this is the GPP policy ID that gets applied to the VXLAN header, and then the permissions that you can see that are allowed here. So it's real simple, like Steve said. You just kind of click the pencil here, and this will allow you to select, which radio buttons that you want to allow for these roles to be able to talk to each other. And so again, right now, all we have is employees can talk to employees IoT, but employees and contractors are not allowed to communicate based on the policies that we see here. And just to show you that real quick. So you can see it's allowed in both directions. Okay, let's see where we're going next with this. And to show you kind of what's going on underneath the hood. So when you lay down those roles, which are globally applied, if we just kind of go down and we just look at the roles that gets pushed down there, you can see that those are the same roles that we have configured. And then if you do show class commands, this is where you can see where we've allowed, employees IoT and employees to talk to each other. And so, as Steve mentioned as well, as soon as you start applying multiple roles, you can see how difficult the configurations get. So having this centrally orchestrated is huge. Okay, and let's see where am I going next? Okay. So if we look at these 2 switches. So I've got the ports here that are talking to each other. Again, 3125 and 1337 both have the contractor's role applied to it. And then on the 6300, the employees IoT port and the employees are allowed to communicate. So I've got traffic flowing between those, and I can show you what that looks like right here. So these are 2 VMs that take up the employees and the employees IoT role. And so you can see that they're able to talk without any problem. And then the Ixia traffic that I've got going, I'll just show you that really briefly. So just traffic flowing in between the 2 devices, no packet loss whatsoever. And so what we're going to do is we're actually going to change things. So let's go, we'll get into ClearPass. And what we're going to do is change the port assignment from contractors to employee. Okay, go ahead and save that. Then I'm gonna have to go out and bounce the port. So let's just go over to clients here. Okay, so we're looking for 3125 here. And we're just gonna bounce this port. Okay, and if we go back to the switch, we should see that that role has been changed. So now you see that the role changed from contractors to employees. And now we should start seeing some traffic loss here. And that's exactly the case. We're seeing packet loss because they're now, the roles are not allowed to talk to each other. So let's see what's next. Yeah, so what we want to do now is just go and take a look at the fabric configuration that gets pushed down. So let's go in. To CX Roseville. And the fabrics wizard, as you can see, is right here, just the tile within the UI groups. And so this is where we've defined the Roseville campus fabric. And if we just edit that to see what we push down, so you can see we've got a name for Roseville campus fabric, the AS number, the devices that we specified, and the personas that are attached to them. One thing of note is you do have to define a border in order for this to progress through the wizard. And the recommendation is if you don't have a border in the environment, then just use one of the route reflectors because they can take on dual roles. So you'd specify route reflector and border, and that would allow you to continue through the wizard. And so just as Steve showed previously, this sets up all of the BGP stuff for the overlay network. Stub tunnels are not in play in this environment, but they will in a future demo once we have the AOS 10 gateways that we can use. And then that's pretty much it for this wizard. So that lays down the BGP configuration. And then for EVPN in the overlay networks, this is where you'd create segments for them. And so you define the Anycast gateways, DHCP relays if you have them, the roles that you want applied to those specific devices. And this is where you'd select the edge VTEPs that you're going to apply those Anycast gateways to. And then you just click save. So that's pretty much it. So as you can see, we've got the two segments there, VLAN 10, or I'm sorry, VLAN 12 and VLAN 13. And so the next thing that we want to do is, well, let's just go and see what that looks like from a device perspective. Yeah, so we just take a look at one of these. You can see this is where the BGP configuration got applied from the Fabric Wizard, the same name that we applied. One thing I failed to note as well is you do have to define two loopbacks for communication with the BGP. You have to have loopback 0 and loopback 1 defined, or the wizard will fail to push the configuration down. So, and so in this case, we're using loopback 0 for the BGP configuration, and then loopback 1 as the second loopback, which is this address here, the source 10255.6, and also the VXLAN configuration there. So on the border, it's a little bit different that you don't have EVPN pushed here. Oh, sorry, just one sec. You can see we don't have the Anycast gateways pushed to borders, but we do to the edge devices. And so the Anycast gateways are pushed to each of the edge devices, but not the borders. And so that's what I wanted to show for what gets pushed down from BGP. Let's see, I've already shown the class commands. So I think the next thing I want to do is let's go ahead and alter the role definition so that these two client ports are not able to connect to each other anymore. So let's just bring this down. Okay, so we still have traffic flowing between them. So now what we're going to do is just go up to the role definitions. And this is under the global settings again. Security. client roles, and now what we're going to do is we're going to alter this so that these are not able to talk to each other anymore. Just going to uncheck these guys, sign and save. And let's go down and see when these devices synchronize. Okay, so this should kick off in a moment, and the roles will get, or the class commands will get altered on the devices. Just while we get some time waiting for that, I can go ahead and just show you packet capture that illustrates, the VXLAN header itself and where to look for as far as the group policy ID that we've applied through the role definition. So this is a capture just taken between the IXIA ports that are transmitting traffic between each other, and you can see the VXLAN identifier VNI there, and also the group policy ID that we identified at Central. Okay, so this is synchronizing, and that's a good sign. This will take a moment for all of these to get pushed. And what we should see in a moment is that this traffic also gets interrupted. Some timeouts that must not have fully pushed yet. We'll run class commands. So employees, yeah, so that's the case. So this right here, that should have stripped the rule for employees IoT, and it
you